I'm going to go ahead and give you some examples for the test. I'm going to let you do the odd numbers. I will do the even, and then I'll kind of do randomly certain problems. So like I'll start with number 2. It's asking state the domain, the range of each function using the specified notation. So I know that the domain is going to be from negative infinity to positive infinity. From negative infinity to positive infinity. And of course it's going to be parentheses. Now the range, you notice that the lowest y value is negative 1. So the range is going to be from negative 1 to infinity. Or you can say y is greater than or equal to negative 1. And then for the domain, it could be all reals. For number 4, you have to graph each function over the interval negative 5, 5. Find the domain, range, and intercepts of the function, then find the max and minimum values over the interval. So I'm going to go ahead and graph it using my TI-84 calculator. And if you have graphs, go ahead and just clear them. And then what you're going to do is you're going to have parentheses around 4 plus x. And then divide by 2. Let's graph so we can see how it looks like. So there's your graph, and of course I do want you to sketch the graph on your paper. So if you want to sketch the graph, go to your table. You probably want to start with negative 5. And so what I'm going to do is I'm going to go ahead and make the table here on my, so I have on the whiteboard, so we have x and y, and I'm going to start with negative 5. When x is negative 5, we know it's negative 0.5. When x is negative 4, we know it's 0. Negative 3 is 0.5. Negative 2 is 1. Negative 1 is 1.5. 0 is 2. And I'm going to continue making my graph, my table here. So we have 1 is 2.5. I'm going to go ahead and scroll down. 2 is 3.5. 3 is 2 is 3. I'm sorry. Let me make that correction. 2 is 3, and 3 is 3.5, and we have 4, which is going to be 4, and 5 is going to be 4.5. So you have 4.5, and this value here is your max. This value here is your minimum. And what I'm going to do is I'm going to go ahead and sketch the graph here. Go ahead and graph, right? So I have my x-axis, my y-axis, my x-axis, and I have negative 5 is 0.5. 1, 2, 3, 4, 5. 0.5. Negative 4 is 0. So let me erase this. You probably want to have some graph paper. I'm just going to sketch it here. So here's your y-axis. Here's your x-axis. And of course, it looks like this on the TI-84. And this right here is your x-axis. It's your x-intercept, which is -4, 0. And this right here is your y-intercept, which is 0, 0, 2. So this is your y-intercept, this is your x-intercept. And once again, your max and your min are shown on the table. So here's your max value, and here's your minimum value, okay? Let f of x equals 3x squared and g of x equal 2 minus 5x. Perform each operation. So for number 5, we have f of x minus g of x. So you have 3x squared minus 2 minus 5x. So we have 3x squared. You have to distribute the -1. So -1 times -5x is plus 5x. And -1 times 2 is -2. Okay, so f of x minus g of x is 3x squared plus 5x minus 2. And if I were to graph this, you're gonna go ahead and press y equals. You want to clear this. We have 3x squared plus 5x minus 2. Graph it. And you notice that you have the graph here. I'm going to go ahead and show it down here. So the graph looks like this. So the domain is going to be all reals. The range is going to be y greater than or equal to, and that's going to be -2. Okay. So now we're going to go ahead and do number 6. And number 6, we have f of x times g of x. So we have 3x squared times 2 minus 5x. So it's going to be 3x squared times 2, which is 6x squared. 3x squared times -5x gives you -15x cubed. And the way you would write that into the calculator, I'll go ahead and show you. Go to y equals, clear it. You have 15x cubed. In this case, we have cubed. Cubed. And it's negative. Plus 6x squared. I'm going to go ahead and graph it. So I'm going to go ahead and draw it right here next to it. And it looks sort of like this. So your domain is going to be negative infinity to positive infinity, which is going to be all reals. And your range is also going to be negative infinity, positive infinity, all reals. For number 7, we're going to evaluate f composition of g of 0. So how do we do that? You're going to rewrite it as f g of 0. So you first have to do g of 0. So wherever you see the value of x, you replace it with a 0. So 3 times 0 plus 1. 3 times 0 is 0 plus 1 is 1. So g of 0 is equal to 1. Then we have f of 1 equals 1 squared, which gives you 1. We're going to go ahead and do number 9. We have g of f of 0. So we have g f, we're going to evaluate f of 0. So it's 0 squared. So f of 0 is equal to 0. Since we know that f of 0 is 0, now we're going to evaluate g of 0, which is equal to 3 times 0 plus 1. 3 times 0 is 1. 3 times 0 is 0 plus 1 is 1. So g of 0 is equal to 1. So we have g of f of 0 is equal to 1. And for number 7, I forgot to tell you, f of g of 0 is equal to 1. We're going to find the inverse for the given function. So we have 2, 1. So it's 1, 2. 3, 5. So it's 5, 3. Negative 2, comma 0. This one's negative 1, negative 1. And 6, negative 4. So what you're doing to find the inverse, you got to switch the x. 11, we're going to go ahead and write, we have y equals 1/2 x plus 1. So to write the inverse, you got to switch the x and the y. So x equals 1/2 y plus 1. You're going to subtract 1. So you have 1/2 y equals x minus 1. And then since you're multiplying by a half, you're going to multiply by the reciprocal, which is 2 over 1. That becomes 1. So you're left with y, and you have 2x minus 2. So the inverse of f is going to be 2x minus 2. Number 12, we have y equals 5x plus 2. Switch the x and the y. So x equals 5y plus 2. Solve for y. Subtract 2 from both sides. So you have 5y equals x minus 2. And then the last step is to divide by 5. So to write the inverse, you're going to write the inverse of f equals x minus 2 divided by 5. For number 13, I'm going to sketch a graph. So we have y equals negative x plus 1. I'm going to graph it. But what I'm going to do is I'm going to go to my table. Start at negative 2. So here's my table. We have x and y. We have negative 2, 3, negative 1, 2, 0, 1, 1, 2. I'm sorry, 1, 0, 1, 0, 2, negative 1. Here is going to be my inverse. Remember, you just have to switch the x and the y. 3, negative 2, 2, negative 1, 1, 0. So let me go ahead and show my graph. That's the y-axis. That's the x-axis. Negative 1, negative 2, 1, 2, negative 1, 2, 0, 1, 1, 0. So here is my line. Y equals negative x plus 1. My inverse, 3, negative 2, 2, 3, negative 2, 2, negative 1, 1, 3, negative 2, 2, negative 1, and then 0. 0, 1. So it's going to kind of look like this. So this is my inverse. So what you're going to do is you're going to make a table of y equals negative x plus 1. And then you're going to switch the x and the y and then sketch a graph. Okay? Let's go ahead and do number 14. So we have y equals, I'm going to go ahead and clear this, x squared, oh, that's the wrong one, x squared plus 2. Go to your table, and I'm going to go ahead and make a table of my equation. So we have negative 2, 6, negative 1, 2, no, negative 1, 3, I'm sorry, negative 1, 3, 0, 2, 1, 3, 2, 6. And then to write the inverse, we have 6, negative 2, 3, negative 1, 2, 0, 3, 1, 6, 2. So let me go ahead and draw my y-axis and draw the x-axis. So we have negative 2, 1, 2, 3, 4, 5, 6, so it's 6 here. Negative 1, 3, 0, 2, 1, 3, and then 2, 6. So it's going to look like this. Of course, it's a parabola. Now we have 2, 0, 3, so it's going to be sideways. Okay, so Here is the function, and here is the inverse. And to find the inverse, you just have to switch x and y. You gotta switch the x and the y. Number 15, number 15, we're solving the equation absolute value of 3x minus 6 minus 7 is equal to 14. Remember, that you have to work with the absolute value. So if you have a minus 7, then you first have to add 7 to both sides. So you have the absolute value of 3x minus 6 equals 21. Now you have to write your two equations. So now you have 3x minus 6 is equal to 21, or 3x minus 6 is equal to negative 21. And then you solve this equation by adding 6 to both sides. So you have 3x equals 27 divided by 3, so x equals 9. Okay. The next one, you have to add 6 to both sides. So you have 3x equals negative 15. Then divide by 3. So x equals negative 5. Okay. Number 16, you have a 3 that's in front of the absolute value. So you have to divide by 3 first. Now you have the absolute value of 2d minus 1 equals 7. And now you can separate into the two equations. So you have 2d minus 1 is equal to 7, and you also have 2d minus 1 is equal to negative 7. You have to add 1 to both sides. So it's 2d equals negative 6. 2d equals 8. Divide by 2. So d equals 4. And over here you divide by 2. So d equals negative 3. We're solving each of these inequalities. Here we have a 2 in front of the absolute value. So you have to divide by 2. Divide by 2 first. So you have the absolute value of w plus 6 is less than or equal to 5. So now we have two possibilities. So it's w plus 6 is less than or equal to 5. W plus 6. Now you got to change the inequality. Greater than or equal to, and then instead of 5, it's going to be negative 5. Okay. You subtract 6 from both sides. So you have w is less than or equal to 1. And here you subtract 6 from negative 5, you have w is greater than or equal to negative 11. So the solution is w is less than 1 and w is greater than negative 11. So you have negative 11, 0, you have 1, close circle, less than 1, so it goes in this direction. The other one is greater than negative 1, is in this direction. So it's right here. The solution is the intersection. (20) has that absolute value plus 1, so you have to first subtract 1. So you have the absolute value negative q plus 4 divided by 5 is greater than 1. So now you're going to have negative q plus 4 divided by 5 is greater than 1. Negative q plus 4 divided by 5 is less than negative 1. So remember, you want to have the absolute value by itself. And that's what we have. We have the absolute value is greater than 1. So now what we're going to do is we're going to multiply both sides by 5. And these two are going to be 1. So you have negative q plus 4 greater than 5. Subtract 4 from both sides. So you have negative q is greater than 1. Divide by a negative 1, and that changes the inequality. So q is less than negative 1. For the second one, you're going to multiply by 5 also. Of course, these cancel. You have negative q plus 4 is less than negative 5. Subtract 4, subtract 4. So you have negative q is less than negative 9. Divide by negative 1. So q is greater than 9. So it's going to look like this. You have negative 1, 0, 9, open circle in this direction, greater than 9, open circle in this direction, okay? And that's an open circle, not closed. (21), that is a 1/2. So you have 1/2, my mistake, 1/4, absolute value, x plus 2 is less than or equal to 1. So you multiply both sides by the reciprocal. Remember, you have to, whatever's outside the absolute value, you have to address. So the 4's cancel. So you have the absolute value of x plus 2 is less than or equal to 4. So you have x plus 2 is less than or equal to 4. And you have x plus 2 is greater than or equal to negative 4. Subtract 2 from both sides. So you have x is less than or equal to 2. Subtract 2 from both sides. You have x is greater than or equal to negative 6. So to graph the solution, you have negative 6, 0, 2, close dot, and it's greater than negative 6, so it's going to go to the right. Less than or equal to 2 goes to the left, so the solution is right here. Okay. Graph each absolute value function, find the domain, the range, and intercepts of the function, find the max and minimum values of f of x over this interval, analyze the symmetry of the graph. What we're just going to do is we're going to find the domain and range, find the intercepts, and then we're going to find the axis of symmetry, okay? So I'm going to go here to the TI-84, and we're going to go to math, number, absolute value, and we're going to type in x. Remember the transformation lesson? That -1 means that the graph will be shifted 1 unit down. So we're going to go ahead and look at our graph, and you're going to see it does shift 1 unit down. And if I want to look at my table, I'm going to use my table to graph this. You have -2, 1, -1, 0, and then 0, 1, 0, -1, 1, 0. So it looks like this. So your x-intercept is -1, 0 and 1, 0. That is your x-intercept. Your y-intercept is 0, -1. Your axis of symmetry, which is actually x equals 0. That is your axis of symmetry. And then your domain, -infinity, +infinity. The range, y is greater than or equal to -1. That's the lowest point. Y is greater than or equal to -1. At this case, you don't have to worry about maximum and minimum values over a given interval. So we found the x-intercept, the y-intercept, the domain, the range, and the axis of symmetry. Okay. I'm going to talk about the different transformations. The -1 is going to shift the parent function down 1 unit. Okay. The +2 shifts to the left. And the 0.5 is going to make the graph narrower. It's going to make it narrower. So I'm going to go ahead and graph that. So it's 0.5, and then you go to math, number, absolute value of x, +2, and then you have a -1. So I'm going to go ahead and graph it. And you see how it's more, I'm sorry, not narrow, it's going to be more wider. It's going to be more wider. So if we look at the table, I have -2, -1. -2, -1. 0, 0. Okay. -4, 0. So you know it's more wider. The axis of symmetry. X equals -2. The x-intercept, 0, 0. And -4, 0. The y-intercept is 0, 0. And those are the items that we had to find. Choose the graph that corresponds to each absolute value function. 25, that 1/4 is going to make the parent function wider. Let me go wider. 26, the +3, it's going to shift left. 3 units and shift up 2 units, and we're talking about the parent function. And for 27, the 1/2 is going to make it wider. The 1/2 is going to make it wider. The -3, is going to shift the parent function to the right, and the -2 is going to shift the parent function down. So you can tell that 25 is going to pair up with B, 26 is going to pair up with C, and 27 is going to pair up with A. It's graph A. And the way you check that is by actually graphing in the graphing calculator. I'm going to let you do that, okay? So 25 is going to get wider. 26, the +3 is going to shift it to the left. The +2 is going to shift it up. And then the last one, the -3 is going to shift it to the right. The -2 is going to shift it down, and the 1/2 is going to make it wider. I'm going to draw the parent function. You notice that the vertex is at 0, 0, of course, and we know now the new vertex is at -1, -1. So what actually happened? If I wanted to write the equation of the new function, I know it's going to be absolute value. I know it's going to go down 1 unit, so it's -1. I know that it's going to go to the left, so it's going to be +1. So y equals the absolute value of x + 1 - 1. If you want to check it, go ahead and make sure you graph it. I'm going to leave that up to you. For 29, the parent function is shown. We have y equals, I know it's going to be absolute value. I know that it's shifting up 1, 2, 3, 4, so it's +4. Since it's going to reflect, in other words, it's kind of switched, it's going to be a negative right here. That's a reflection. Also, I did notice that it became wider. So I'm going to write -1/2 absolute value of x + 4. Why did I say that? Because I noticed that after 2 units it went up. Here I see it's 1. So 31, 32, and 33, I'm going to show you how to graph that using the TI-84 calculator. Make sure it's on. You have y equals, you can clear it here. So you have the absolute value, which is going to be math, number, absolute value of x -1 -2. Now, before we go any further, I do want to talk about the transformations. The -1 is going to shift the parent function to the right 1 unit. the minus 2 is going to shift parent down 2 units. So that minus 1 is going to shift the parent function to the right, and the minus 2 is going to shift the parent function 2 units down. So I'm going to go ahead and graph it. And you notice that it went to the right 1 unit, and it went down 2 units. And so the new vertex is going to be 1, -2, right? And then the axis of symmetry is going to be x equal 1. Okay. If we were to read this, it would be y is less than. Less than implies that it's going to be anything that is below -2. So I'm going to go to the y equals here, and I'm going to shade below -2 and graph. So if I were to sketch this, I know that my transformation is 1, 1, -2. And I know that my graph is going to be a dotted line. And I know that it's going to be shaded below, just like it shows on the TI-84. Therefore, everything that is below this inequality line, below this equation, is going to be a solution. Nothing on this line will be a solution, or anything above it. Now, 32, we have that plus 4, so we first have to subtract. We have to subtract 4 from both sides, since we want the y by itself. So we have y is greater than or equal to the absolute value of x plus 1 plus 1. And this says y is greater or equal. So that means that we're looking at the values that are greater than 1. So if I were to graph this, and I know the transformation, that plus 1 that's inside the absolute value means it's going to shift 1 unit to the left. Now that plus 1 on the outside means it's going to shift 1 unit up. So the new vertex is -1, 1, and it's a solid line. And since it says y is greater than or equal to, so the solution will be on the line, and then everything that is greater than 1. So we wanted to check this, we would graph it. We have y equals, and we're going to go ahead and shade. We're going to shade up. Plus 1. And that isn't a -1, it should be plus 1. And so there's my graph. I'm going to let you do the last one on your own. 0.5y plus 1.5 is less than or equal to -0.25x minus 1. So what you're going to do is you're going to subtract 1.5 from both sides. So you have 0.5y is less than or equal to -0.25 absolute value of x minus 1 minus 1.5, and then you divide by 0.5, divide by 0.5, divide by 0.5. So y is less than or equal to and you have 0.25 divided by 0.5, 0.25 0.25 divided by 0.5 gives you 0.5, which is a half, so it's negative 1/2 absolute value x minus 1, and that 1.5 divided by 0.5 gives you 3 minus 3. So that 1/2, is going to make the graph wider. The negative is going to reflect. The minus 1 is going to shift to the right, and the minus 3 is going to shift 3 units down. Okay. Go ahead and graph. 34, the parent function is right here. That's a parent function. You notice there's a reflection. So you have y, so it's going to be a negative absolute value. The vertex is up here, so it's going to shift to the right. So it's x minus 1, and then it shifts up 2 units. And it is equal, since I know it's a solid line, and it's shading down, so it's less than. So it's going to be y is less than or equal to. The negative means it reflects it. The minus 1 it shifts to the right, and the plus 2 shifts up. So that is the inequality.